Hey, thanks for joining me today. We're going to talk about a little bit about the relationship between fractions and decimals. Primarily what we're going to do is take fractions and turn them into decimals. We'll talk about going the other direction later on, and then we'll do a quick area problem, area of a triangle. That may be a new formula for us. Okay, first write as a decimal, and this is the trick. If you have a fraction, you just take the numerator and divide it by the denominator. So 1 over 4 is the same as 1 divided by 4. And we can do this with long division. So 4 goes on the outside, 1 goes on the inside, and you say to yourself, well, that doesn't fit. But remember, we can put a decimal point after the 1, and then we can put as many zeros as we like or need. So we won't need all those. 4 goes into 1 0 times. Bring the decimal up. 4 goes into 10 2 times. 4 times 2 is 8, and 10 minus 8 is 2. Bring down the next 0. We need another 0. 4 goes into 25 times. 4 times 5 is 20. Subtract, and we end up with 0. And now we don't need the rest of the zeros because we'll never have a number bigger than 4 that we can say how many times 4 goes into that's greater than 0. So 0.25 is the answer, and that is equivalent to 1/4. So 1/4 is equivalent to 0.25 in decimals. Now, it's important to recognize some basic fractions. These are the ones I would have memorized. 1/4 is 0.25. 3/4 is 0.75. Think about quarters, 25 cents, 75 cents, 1/4, 3/4. 1/2, of course, is really important, 0.5. And then it's also a good idea to keep 1/3 is 0.3 repeating, and 2/3 is 0.6 repeating. Your calculator will not tell you repeating. What it will say, well, for 1/3 it will say 0.3333, and then it'll come to an end somewhere. And for the 2/3 it'll say 0.6667. So it rounded up at the last space possible on your calculator screen. So it's important to recognize that your calculator is of limited value in dealing with some decimals, because some decimals are just too long. Some of them are infinite, 1/3, and 2/3 are infinite, and they go on forever. So the calculator can't handle that, so they just round it off at some point. And it's important to recognize that those are not precise values. Okay, let's go on to the next one. I think that's probably good enough for memorizing right now. 31/40, of course, means 31 divided by 40. So let's do that with long division. 40 goes into 31 0 times, but we can put a decimal point and as many zeros as we need. 40 goes into 310. Oh, let's see, I think that's going to be 6 times. I'm going to guess 6. I may be wrong. So 6 times 0 is 0, and 6 times 4 is 24. Oh, I think I'm wrong. What do you think? Is it 7 times? Well, does this ever happen to you? I guessed it was 6 and I was wrong, so now I'm going to have to do 7. Much better. 8 would be too big, but I'm going to have to erase this. So either use a nice fancy board like I have, or a pencil, or be sure to check your math off to the side when you're doing your calculations. Okay, so 7 times 40 is 280. And then we subtract that, we get 30. Bring down a 0. 40 goes into 300. Well, it's, again, 7 times 280. This time we're going to get 20. Bring down another 0. 40 goes into 200. Well, 5 times. 5 times 40 is 200. And so this one worked. Now notice that this answer looks an awful lot like that 0.6667, right? It looks like that was going to be a repeating decimal, but it turned out not to be repeating. It just went repeated 7s for a while, and then it terminated with the 5. So no estimating involved here. The next one, and the last one that we're going to do, and I'll use the space over here, 5 divided by 3, 5/3. Notice that the number on top is larger than the number on the bottom. So this is an improper fraction, which means that we're going to have an answer that's bigger than 1. 3 goes into 5 one time. 1 times 3 is 3. Subtract it from 5 to get 2. And then we bring down the 0, move up the decimal. 3 goes into 20 6 times. 3 times 6 is 18. Subtract and we get 2 again. Bring down a 0. 3 goes into 20 6 times. 3 times 6 is 18. Subtract, we get 2. Bring down a 0 is 20. And now we can see that this is just going to repeat over and over and over again. Every time we're going to get 20 minus 18 is 2. Bring down the 0. 20 minus 18 is 2. And so this 6 is just going to keep on repeating. So I'm going to say this is 1.6 with a bar over it. That means repeating instead of just having a bunch of 6s. I don't want to have a bunch of 6s and then just have them trail off. And I don't want to round it to, say, well, it's good enough, and then round it up to 7. I'm going to be very precise and say it is a repeating decimal. It's a repeating 6 over and over again, so I just put a little bar over the 6, and that tells me what I need to know. Okay, now, one of the most useful, one of these great uses for this is being able to compare fractions. When you have two fractions like this, 1/9 and 2/17, which one's bigger? It's really hard to tell. So there are various tricks that you may have used in the past, but the trick we're going to do today is we're just going to turn them into decimals. So I'm going to take 1/9 and turn it into a decimal, and then 2/17 turn it into a decimal, which means I have to do long division twice. 9 goes into 1, 0 times, put on some extra zeros. 9 goes into 10, 1 time. 10 minus 9 is 1, bring down the 0, 1 time again, and we can see that we're going to get a repeating decimal here. So this is 0.11111, right, forever. Now, why did I do that? Well, you'll see in just a minute, because now I'm going to do 17 into 2. 17 goes into 2 0 times. 17 goes into 20 1 time. 20 minus 17 is 3. Bring down another 0. 17 goes into 30 1 time. 30 minus 17 is 13. Bring down another 0. And 17 goes into 130. Well, that's going to be a bunch of times. It's going to be, I don't know, let's say it's not 5, it's 4, I think. So 17 times 4. 28, 4, 5, 6. No, I'm so far off. 14, 28, yeah. I know why I misthought that out in my head, so I'm completely wrong. 68 is way more than that. Let's say 7 times. So 17 times 7. 7 times 7 is 49. 7 times 1 is 7, plus 4 is 11. And let's see, yeah, it'd be 36 would be the next one up. So 7 times, and 119, and we're going to subtract, and that's going to be 11. Okay, now we can keep on going because we have a remainder. So we can add another 0 and say how many times does 17 go into 110? And it's going to be 6 times, and we can keep on going. I don't know how far this would go, but we have enough to compare these two. I'm going to line them up side by one over the other. So I'm going to put 2 17ths underneath 1/9, so 0.1176. Okay, and it keeps on going. And so how do we know which one is bigger? Well, we first look at the ones place, and they're equivalent, both 0. And then the tenths place, they're equivalent, both ones. Then the hundredths place, both equivalent, 1/100th. And then we look at the thousands place, and the 1/9 has a 1 in the thousands place, but the 2 17ths has a 7 in the thousands place. So 2 17ths is just a teeny bit bigger than 1/9. And so that is the greater problem. All right, well, that was tricky and challenging. Let's do another one, and this is just a different type of question that's asking the same thing. It says order from smallest to largest, and I have 3 numbers this time, and we're going to write them in order. The first number is 6/9, then 0.663, and then 0.668. Now, the way that we're going to do this, no matter how many decimals or fractions we get, is we're just going to turn them all into decimals. So I've made it easy for myself here because I only have one fraction. 6/9 is 9 into 6, or 6 divided by 9. And 9 goes into 6 0 times, so we put a decimal point and a 0, and then we say 9 goes into 60 5 times. No, 6 times. 6 times 9 is 54. Subtract, and we get 6. And then we can add another 0. And 9 goes into 60 6 times. 6 times 9 is 54. Subtract, we get another 6. And so we can see that we're just going to keep getting 6s. So 6/9 is 0.66666. Okay, you get the idea. Now, let's line these up. I'll give myself a little bit of room here. So I've got the first number is 0.666. Repeating, it goes on forever. The second number is 0.663, stop. And the third number is 0.668. And once again, can we compare these? 0, oops, I used my highlighter. So the ones place is 0s, the tenths place is 6s, the hundredths place is 6s, so they're all the same size so far, but when we get all the way down to the thousands place, we notice that the numbers are different. The first number has a 6, the second has a 3, and the third one has an 8. So the smallest one is the 3, so that is our smallest number. And I'm going to write that down, 0.663. Then the first one has a 6 in that spot. That's our next biggest number, 6/9. And then the last one has an 8 in that position, 0.668. That's the largest number. So we can put commas there, or we can put less than signs if we want to show that we have ordered these from smallest to largest. Finally, we are going to find the area of the triangle. Now, I very purposely constructed this problem with some extraneous information that we do not need. And in order to answer this question, the area of a triangle, we need to know what the area of a triangle formula looks like. And so we need to have this in our notes. The area of a triangle is 1/2 times the base times the height. Now, what are the base and the height? The base of a triangle is just any of the sides. So any of the sides could be the base. Oftentimes we'll give it to you with the base, I like to say, sitting on the ground, resting on the ground. But we don't have to. So just recognize the base could be any of the sides. And the way you tell which one to use is, generally speaking, the height. The height is the distance from the tip-top point of the triangle, if the base is on the ground, straight down to the ground. And you can see that we have that measurement right here. That's that 13 inches. Now, if I turn the triangle over, and if you can imagine just me rotating it over like this, so that this side is 12.7, and this side is 14, and this side is the 15.2. Then the 15.2 would be the base, and the height would be whatever this distance is here. But because we don't have that distance, we can't use 15.2 as our height. And likewise, I could use the 14 inches as the base, but then we would need to know this distance straight down to the ground there. We would need to know this distance. And we don't know that distance, so we can't use the 14 inches as the height. So which one is the base is going to really depend on which one we have the height that goes with it. So the height for this triangle is 13 inches when the base is 12.7 inches. So we write that down. B equals 12.7, H equals 13, and then we fill them into our formula. The area is 1/2, 0.5. Notice I just kind of automatically turn my fraction, 1/2, into a decimal, 0.5. Base, 12.7, and then the height, 13. Now this is a long multiplication problem. I'm multiplying three numbers. I'm going to take the first two arbitrarily. I could have taken any two, but I'll just take the first two. And I'll do that multiplication first. So 12.7 times 0.5. 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. And 5 times 1 is 5, plus 1 is 6. And then 0 times everything is 0, so this is just going to be 0 plus 635 is 635. And then I count the decimal places after the places after the decimal point, 2 spaces, so the answer is 6.35. Now that makes perfect sense if we were estimating, because half of 12 is 6, so half of 12.7 is 6.35. 6.35, that's the answer to the first two multiplied together, times 13, and now we have another multiplication to do. So 6.35 times 13. Notice how I'm carefully showing all my work. 3 times 5 is 15. 3 times 3 is 9, plus 1 is 10. 3 times 6 is 18, plus 1 is 19. Put a 0. 1 times 5 is 5. 1 times 3 is 3. 1 times 6 is 6. And then add, and we get 8255. How many decimal places are there? 2 places after the decimal in 6.35, none in the 13. So the answer is 82.55 inches squared, square inches. So the area of that triangle is 82.55 square inches. Thank you very much for watching, and have a wonderful day.